Welcome to the class. This chapter we are going to talk about database. First of all, we need to know why data matter. The amount of data being generated, stored, and processed is growing by leaps and bounds. And as more and more of the world becomes digital and products we use every day such as watches, refrigerators, and such become smarter, the amount of data that needs to be generated, stored, and processed will only continue to grow. Over the past 2 decades, data has become a strategic asset for most organizations. Databases are used to store, manipulate, and retrieve data in nearly every type of organization, including business, healthcare, education, government, and libraries. What is database? A database is a structured collection of data that allows people to extract information in a way that meets their needs. Let's take a look about data and information, these two words. Historically, the term data referred to facts concerning objects and events that would be recorded and stored on computer media. For example, in a salesperson's database, the data would include facts such as customer name, address, and telephone number. The traditional definition of data now needs to be expanded to reflect a new reality. Databases today are used to store objects such as documents, email, tweets, Facebook posts, GPS information, maps, photographic images, sound, and video segments. An expanded definition of data is a stored representation of objects and events that have meaning and importance in the user's environment. The term data and information are closely related, and in fact are often used interchangeable. However, it is useful to distinguish between data and information. We define information as data that have been processed in such a way that the knowledge of the person who uses the data is increased. Why are databases useful? First, the separation of data description from the application programs that use the data is called data independence. This property of database systems allows an organization's data to change and evolve without changing the application programs that process the data. Second, by eliminating or controlling data redundancy, we greatly reduce the opportunities for inconsistency. For example, if a customer's address is stored only once, we cannot disagree about the customer's address. When the customer's address changes, recording the new address is greatly simplified because the address is stored in a single place. Third, a database is designed as a shared cooperative resource. The same data is used by everyone who had the permission to use the database. And the last one we talked about previously about the data consistency. The data is only stored once in relation databases, which means no data duplication. What are databases used for? To store information about people, for instance, students at the school, employees at the company. And also it can store information about things. For example, products to be sold, books in libraries. And it can store information about events, such as result of races and the hotel bookings. We talk about a lot of definition and the importance of data and how database can be used for. And now we are going to take a look about the structure of a database. Inside a database, data is stored in tables, which consists of many records. Each record consists of several fields. The number of records in a table will vary as new records can be added and deleted from a table as required. The number of fields in a table is fixed, so each record contains the same number of fields. An easy way to remember this is each record is a row in the table and each field is a column in the table. A table contains data about one type of item or person or event and will be given a meaningful name. For example, a table of patients called patient. And each record within a table contains data about a single item, person, or event. So the record can be a hospital patient. And each field in the record contains a specific piece of information about the single item, person, or event stored in that record. So the field 1 can be the patient's first name. So we called first name. So let's think about it. What can be field 2, 3, and 4? The patient's family name, the patient's date of admission, the patient's ward number, the patient's bed number. They all can be the field. Now, for example, a table of books. I will give you 10 seconds to think about it. What the table name will call, and what single item or person or event can be recorded, and the field. So, the table name can call book, and the record, each one represent a book. The field 1 we can use such as the book title, so we call title. And the second field, we can fill in author. And field 3, we can use publisher. And field 4, we can use ISBN. What is a data type? Each field will require a data type to be selected. A data type classifies how the data is stored, displayed, and the operations that can be performed on the stored value. For example, a field with an integer data type is stored and displayed as a whole number, and the value stored can be used in calculations. There are 6 basic data types that you need to be able to use in database. The first one is text. It is a number of characters. You can refer it as a string we use in programming. The second one is character. It is a single character. The third one is Boolean. It can be true or false, 1 or 0, yes or no. The fourth one is integer. It is stored and displayed as a whole number. The fifth one is real. It is a decimal number. And the last one is date. It can be date or time. At the end of the class, let's review what we learned about this class. First, we know what is database and what it is used for. Second, the structure of database table. A table contains record and fields. And we learned about 6 basic data types, including text, character, Boolean, integer, real, date, time.